For the auto sector, record-high oil costs might seem like bad news. However, the CEO of GM intends to produce compressed air vehicles, which will be unaffected by $50 a barrel of oil. Is it possible to have an automobile that runs on compressed air? What other automobile can surpass or exceed that? GM has lately introduced its innovative zero-emission engine, which will make electric and internal combustion vehicles obsolete. This cutting-edge technology is expected to be the next breakthrough in the automotive industry, driving us towards a more sustainable future for cars. Do not delay and examine this innovative mindset as the CEO of GM introduces a groundbreaking engine that will revolutionize the automotive sector. General Motors has been building cars for more than a century. It has more than 30 production facilities in the United States. GM believes that its business goes beyond the company's boundaries and into the broader communities where it works. GM CEO Mary Barra stated, "As one of the top automakers in the world, we strive to set an example of responsible leadership in a world facing climate change. It is hard to comprehend that compressed air can be utilized to drive cars. Nonetheless, it is accurate, and researchers from all around the world have become interested in the compressed air-operated car, as it is commonly called. It produces zero emissions and is suitable for city driving situations. The automotive sector is striving to minimize the weight of the vehicle as it helps in the better handling of the vehicle and boosts the efficiency of the vehicle. Today, big trucks are renowned for producing a considerable number of hazardous gases like CO2, SO2, etc. Although it seems to be an environmentally friendly alternative, one must examine its well-to-wheel efficiency. The electricity requirement for compressing air has to be considered while estimating overall efficiency. Nevertheless, the compressed air vehicle will aid in lowering urban air pollution in the long run. Polish engineer Louis Makarski created the first compressed air vehicle in France in 1870. It was tested in Paris in 1876 and granted patents in 1872 and 1873. The working basis of the engine was the use of energy stored in compressed air to enhance the gas enthalpy of hot water when it is passed through hot water. In 1984, Uruguay demonstrated a further use of pressurized compressed air for vehicle propulsion. Armando Ragucci was instrumental in the development of these devices there. In 1992, he invented a four-wheeler with a pneumatic engine that could go 100 km on a single tank. Guy Negre, the creator of MDI Group and a former Formula One engineer, created the air car, which uses a compressed air engine, CAE. Guy Negre is located in Luxembourg. An air engine uses compressed air that is kept in a tank to power a compressed air vehicle, CAVE. Compressed air cars use the expansion of compressed air to drive their pistons rather than mixing petrol and air and burning the mixture in the engine to drive pistons with hot, expanding gases. Compressed air propulsion may also be integrated into hybrid systems, such as with battery electric propulsion. We refer to this type of system as hybrid pneumatic electric propulsion. Additionally, regenerative braking can also be employed in conjunction with it. It seems to be an environmentally friendly choice. One must evaluate its well-to-wheel efficiency. The electricity requirement for compressing air has to be considered while estimating overall efficiency. Nevertheless, the compressed air vehicle will aid in lowering urban air pollution in the long run. The temperature of the globe is increasing drastically, and this in turn is creating climatic changes. Fossil fuels are widely employed as a source of energy in numerous domains, such as power plants, internal and external combustion engines, and heat sources in manufacturing industries. The environmental difficulties created by passenger cars are considerable and require a broad spectrum of evolutionary and creative solutions. The most common fuel in these vehicles, petrol, creates carbon dioxide, nitrogen oxide, and unburned hydrocarbons, which are the causes of vehicular pollution. A viable alternative to the gasoline-powered car is air power. Air, which is freely available and is free from pollution, can be compressed to higher pressure at a low cost. Compressed air-powered vehicles, CAVs, offer an efficient way to produce and transmit power while also being environmentally beneficial. CAV technology reduces the cost of vehicle manufacture by roughly 20% because there is no need to create a cooling system, gasoline tank, or ignition system silencers. The engine can be lowered in size. The engine runs on cold or warm air, therefore can be made of lower-strength, lightweight material such as aluminum, plastic, low-friction Teflon, or a mixture. Compared to batteries, compressed air tanks are less polluting to recycle or dispose of. The air tank may be replenished more often and in less time than batteries can be recharged, with refilling rates comparable to liquid fuels. Lighter vehicles inflict less damage on roadways, resulting in lower maintenance expenses. The primary issues with all compressed air vehicles are the engine's lack of torque and the air's high compression cost. The primary downside is the indirect usage of energy. Energy is used to compress air, which in turn supplies the energy to power the motor. For compressed air cars, energy is wasted when electrical energy is converted to compressed air, and when fuel is burnt to drive the electrical generators. Refueling a compressed air container with a home or entry-level conventional air compressor can take up to 4 hours, although service shops with specialized equipment can fill the tanks in around 3 minutes. Tanks grow very hot when loaded rapidly. However, if well insulated, the heat would not be lost but put to use when the automobile is operating. Proponents of this technology believe that CAVs are cleaner and cheaper to operate, since they do not consume fossil fuels and emit zero tailpipe emissions, while offering the power and performance needed for light-duty vehicle use. A research analysis argues that CAVs are the finest solutions and provide the most comprehensive answer to the present urban pollution challenges. They are clean, easy to drive, comparatively low cost, and do not need a lifelong payoff. Their speed, range, and power are restricted today, but further study could produce more beneficial results. It is crucial to emphasize that passenger transportation faces very serious issues like emission of greenhouse gases, health concerns, and large import dependence on petroleum products. Several evolutionary solutions are being developed to lessen the impact of motor vehicles, such as enhanced fuel economy standards and the quicker adoption of hybrid vehicles. One novel solution is seen in CAVs, which solves acute urban pollution problems. CAVs will likely become the potential means of urban transportation in the future. However, greater research on their speed, range, and power would be needed to make that possible. Refilling is achievable in nearly any site or with onboard equipment because the only thing needed is wind, solar electricity river, tidal, or wave hydropower to operate an air compressor, hydraulic pump, or Stirling engine. Low-pressure compressed air is produced by energy recovery systems that combine regenerative braking and suspension, and this compressed air is then stored in an extra pressure tank. Low noise of pistonless rotary engines while using compressed air, which can also be soundproofed because of the low temperature in which it works. Zero fire hazard, which makes it one of the few transportation systems that cannot cause spontaneous or after-collision fire or explosions, like in the case of petrol, ethanol, hydrogen, and also battery vehicles. GM has been working incredibly hard. They have been quite effective at it. First, the problem has been solved using compressed air vehicles. As a result, GM's new compressed air prototype produces performance figures that are very equivalent to ordinary gasoline engines. Sure, the torque isn't quite there yet, however, they're still powerful enough for a standard commuter vehicle. Furthermore, GM has also developed a means to extend the vehicle range. How? By turning the vehicle chassis into one huge pressurized air reservoir. However, this needs the vehicle to be carefully constructed with compressed air engines in mind. This involves particular strengthening of, or even the employment of composite materials such as fiber-reinforced thermoplastics. This allows the vehicle to preserve incredibly low weight while also being significantly safer than utilizing standard high-press tanks, as colliding and rupturing the reservoir won't lead to an explosion, no matter what. GM has completely invested itself in making this engine a reality. They keep researching and developing answers to many existing challenges and are highly devoted to generating a truly wonderful product that will alter the automotive sector entirely. Compressed air vehicle technology is not new. It has been around for years. Compressed air technology provides for engines that are both non-polluting and affordable. After 10 years of study and development, the compressed air vehicle will be offered worldwide. In contrast to cars fueled by electricity or hydrogen, compressed air vehicles are less costly and have a longer operational range. Compressed air vehicles are inexpensive and have a performance rate that stands up to contemporary norms. To sum it up, they are non-expensive cars that do not pollute and are easy to go around in cities. The emission benefits of deploying this zero-emission technology are evident. At the same time, the well-to-wheel efficiency of these cars needs to be enhanced. What are the potential ramifications of this revolutionary engine technology for the automotive industry and beyond? How will this innovation change consumer behavior expectations for vehicles? What ethical considerations should be taken into account as AI becomes more popular in the transportation sector? This marks the end of today's video. We hope you enjoyed it. Kindly hit the like, share, and subscribe buttons. Thanks for watching.